All right, welcome back. Today we are going to start in on Chapter 4 of Campbell's Biology, and this is Carbon and the Molecular Diversity of Life. Start off real simple here with a concept 4.1. Organic chemistry is the study of carbon compounds. That is pretty much a definition, so I can't leave it just there. I have to dig in deeper. All right, so let's pick up with carbon. Most or all living organisms that we know of consist mostly of carbon-based molecules or carbon-based compounds. Everything you look at is different pieces made up of carbon, right? So why carbon? Well, carbon is unique in its ability to form very large and complex varied molecules. Okay? How varied? Well, proteins are largely carbon, DNA largely carbon, carbohydrates largely carbon, lipids, all of these things are all based on carbon compounds. Okay? Part of the reason why carbon has all these abilities is the fact that it has a valence level of 4, right? So here we have carbon sitting in the middle. It can form 4 different bonds, the 4 different things, or it could do combinations of double, triple bonds with one thing, okay? Now, as we stated before, organic chemistry is the specific study of compounds that contain carbon and how you can react these things together, how you can synthesize them, how you define them. All of those things is in the realm of organic chemistry. Now, organic compounds can range from very simple molecules to massive molecules. Okay? Think of a diamond. A large single diamond is essentially one molecule of carbon, right? So it can become massive in nature. Now, most organic compounds also contain hydrogen atoms in addition to the carbon. So you can kind of think of it as utilizing carbons to construct objects based on their shape, and think of it as carbons as Legos, and then anywhere where you don't attach another carbon, maybe you attach a hydrogen there. That's a good place to start off with. We deviate from that, but that's a good place to start. Okay. Now, where did all these organic molecules come from? And how does this relate to the origin of life? Now, again, this is all hypothesis. We don't really know what happened, but there was a guy named Stanley Miller who did a unique set of experiments. What he did is created this contained system. Okay, so we have a glass beaker that has a Bunsen burner underneath, and in it has water, right? And it was probably salt water. Also in here we had things such as methane and ammonia and hydrogen gas and all these other various things. As this heats up, you get water vapor, and all of the gases flow into this chamber. This chamber is equivalent to the atmosphere. This body of water would be equivalent to the sea. Okay? Now, up here in this gas chamber, we had a couple of electrodes coming in, and he would send the spark through. Okay? This is very similar to the effects of lightning up in the atmosphere. So you get water molecules and methane up here, and ammonia and hydrogen gas. You start sparking things, and then you allow that gas to pass into something called a condenser. Condenser is essentially a tube wrapped around the tube, and you can flow cool water through it. This cools down the gas and allows it to all that gas to turn back into a liquid. All that water vapor will recondense and turn into liquid water. Okay, this is equivalent to rain. That rain drips down, goes into the tube, and goes back into the sea. There it gets heated back up, goes back up into the atmosphere, gets hit by lightning, cools down, drops as rain, and we do the cycle over and over again. As he did this experiment, every once in a while he would take a little subsample of it, and then he would do some chemical analysis to see what happens to the original starting compounds that we put in there. Okay? When you do this, you get amino acids, you get hydrocarbons, right? So these are some of the large starting places for all of the organic compounds in life. Okay, we also start off with some simpler compounds such as formaldehyde or hydrogen cyanide, but you start reacting those two together, you start getting these much more complex things. Okay. Now, these experiments and other experiments support the idea that you can get abiotic or a non-biological source of all these organic compounds. Now, if you add in the idea of maybe this isn't happening just in the atmosphere, but also happening near volcanoes, you can get a whole slew of other reactions to occur. With volcanoes, you also have a source of sulfur and hydrogen sulfide. That's what gives eggs that bad egg smell. Also a large contributor to the smell of farts. There you have it. You add that into the mix and put it into the similar type of reaction, you start getting even more complex things such as methionine, and you get all these amino acids built. This suggests that life could also have started, or all the building blocks of life could have been originated from volcanoes, and specifically now we're thinking about volcanoes that occur down at the bottom of the ocean, because there we also have increased pressures and you can get some really unique reactions happening there. And if you actually go down to these thermal vents underwater, you can get a whole slew of really unique life forms that you don't see anywhere else. All these bacteria that are living using chemical reactions that are nothing like we see up on the surface. Alright, so concept 4.1, organic chemistry is the study of carbon compounds. These would include proteins, DNA, carbohydrates, lipids. These are all carbon compounds. Why carbon? It's because it can bond 4 different things at one time, right? So we can build a lot of complex structures. If you start putting carbon compounds and all these starting ingredients into a system that looks like a miniature version of the Earth, we can actually pull out things such as amino acids and hydrocarbons, right? So this gives us an idea of where the starting elements of life may have originated. And we'll pick up this discussion later on about how these pieces might have come together and turned into something alive. At least one idea.